Hi guys, welcome back to my YouTube channel. And today I'm going to be doing something a little different, and I'm going to be giving a little introduction to the topic of solutions. So let's get started. If you've ever been interested in the topic of forensics or crime scene analysis, you'll come to see that a lot of it is related to solutions. This is because analyzing various pieces of evidence, such as bloodstains, fingerprints, liquids, and hair, all include solutions in order to identify them. So let's start off with, what are solutions? In chemistry, a solution is defined as a homogeneous mixture composed of two or more substances. One of the substances is called a solute, which is a substance that is dissolved in the solution. And the other part of a solution is a solvent, which is a substance that dissolves a solute. In every solution, the quantity of the solute is always less than the solvent, so that it is easier to dissolve. In this picture, the liquid is the solvent and the solute powder combine to form this solution. There are 9 possible types of solutions, and all of them revolve around the fact that solutions can be either solid, liquid, or gas. I'll be highlighting a couple of examples from each category on this table. So first is the common one that you guys have probably already heard of, which is salt water or seawater. Salt water is a liquid solution which has a solid solute, which is salt, and a liquid solvent, which is water. And these two mix together to form a liquid solution known as salt water. Then there is our natural air around us, which is actually a solution because the solute is oxygen and the solvent is nitrogen, which actually makes up 78% of the air around us. Lastly, all solid solutions are known as metal alloys. In this specific solution, this is an example of a steel. In this, the solute is carbon and the solvent is iron. These 9 types of solutions are all homogeneous mixtures because all solutions can only be homogeneous in order to be classified as a solution. Now let's look into the difference between a homogeneous and a heterogeneous mixture. I'll take you through the definition and molecular structure of each of these mixtures and what their characteristics are. A homogeneous mixture is a solid, liquid, or gaseous mixture that has a uniform composition. No matter where you sample the mixture, the components retain their chemical identity and they are visibly inseparable. In contrast, a heterogeneous mixture lacks a uniform composition, so samples won't be identical. This diagram shows the molecular structure of a salt water molecule, which is a homogeneous mixture. When the salt starts to dissolve into the water, the Na and Cl atoms dissociate into ions. The individual water molecules stick to both sodium and chlorine. Because sodium is positive, it attracts oxygen, which is negatively charged, and because chlorine is negative, it attracts the positively charged hydrogen. So at a molecular level, the homogeneous mixture may contain multiple compounds or elements, but any given sample will have identical composition and characteristics. The other example is of a heterogeneous mixture, which is milk and cereal. When the cereal is added to the milk, there is no dissociation on the molecular level. You can easily differentiate between the two substances, and every spoonful of milk and cereal could have a different amount of each substance. Therefore, we can conclude that this is a heterogeneous mixture because it lacks a uniform composition. Solutions are used in several different aspects of everyday life. Some of the most common industries where they are being used is the cleaning, food, and automobile industry. For example, bleach is one type of a solution used for cleaning. Then there's mothballs. When naphthalene combines with benzene, it creates mothballs, which are used to protect your clothing from moths and other fiber insects. Then ingredients such as citric acid, glycerin, sodium benzoate, and sucrose combine with purified water to make the homogeneous solution for Tylenol syrup. In industries that make cars and airplanes, they use metal alloys, which, as I had already mentioned, are solid solutions. One of the most intriguing parts of my research was to see how forensic labs use different powders, liquids, and chemicals for their analysis. They rely on 4 primary chemicals to reveal and collect fingerprints: iodine, cyanocrylate, silver nitrate, and ninhydrin. These chemicals react to substances within the fingerprint, such as oil and sweat, making the print change color so analysts can see it better. Fluorescein is a chemical that is used to identify bloodstains and smears, which may appear in different crime scenes. It causes a chemical reaction between oxygen and the hemoglobin present in blood. Thank you so much for watching today's video. And if you learned something new about solutions, please drop a like down below and subscribe for more videos. Thank you. Bye.